Alright, this video is on the classification of differential equations. All you need to know is the order of the equation and whether it's linear or nonlinear. It's nonlinear when the dependent variable, or in this case let's call it y, is y to a power, e to the y exponential, ln y logarithmic, trig, so it could be like sine y, or y with a product of its derivative. And keep in mind, dependent variable is when it's like the output of the function, so y of x is y depends on x, just think of it like that, or like the output would be the dependent variable. So yeah, usually it's y, but just keep that in mind. So let's move on to some practice problems. Alright, so let's find the order of these two differential equations. So what do you think the order of 1 is? The order of 1 is 4, because we have y to the 4th derivative here, which is greater than the 3. And number 2, what do you think the order is for number 2? Number 2 would be 3. And that's because you're essentially distributing this d over dx, making it d cubed y over dx cubed, which makes it third order derivative, which is greater than first order. So it's the highest order for this equation. Here are some examples for classifying whether an equation is linear or nonlinear. So let's start with 3. We're going to look at the first term. So y to the open parentheses 2 end parentheses, that's just y to the second derivative. So this is completely fine, and it's linear. The next term, x times y prime, this is also linear. And then finally, e to the x times y, this is also linear. So this means the whole equation is linear. So every single term of a differential equation must be linear so that you can consider it linear. And a good way to go about it is, it's good to know this chart here of when it's nonlinear, or just think about like if it's a derivative by itself or times the independent, then it would always be linear. And like if you have adding terms like this is still linear. So as long as it's not like a complicated function like this, or a product of with itself, then it'll always be linear. So yeah, this is generally like what a linear would look like. A linear equation. So number 4. What do you think number 4 is? Number 4 would be nonlinear. And that's because already the first term is nonlinear, so that automatically makes the entire equation nonlinear. And the first term is nonlinear because it's y with a product of its derivative. And we already established that this means it's nonlinear. Alright, here are some more examples to classify whether it's linear or nonlinear. So number 5, let's go term by term for good practice. So t cubed times d squared y over dt squared. This would be linear. That's because y is the dependent variable in this case, because you could notice that from dy over dt, if it's on the top, if it's the numerator part of the derivative, then it'll be dependent. And ln t dy over dt, this is also linear. However, e to the y, this is nonlinear, automatically making this entire equation nonlinear. So keep in mind, since y was a dependent variable, since it's an exponential, it's going to be nonlinear. And ln t dy over dt, that was completely fine because t is independent, so we don't worry about that. So number 6, dx over dt plus x cosine t plus x squared. So in this case, the dependent variable is x. So this is linear. X cosine t is also linear. And x squared, what do you think? This is nonlinear. Because remember, if it's the dependent variable to a power, then it'll be nonlinear. So this entire equation is nonlinear. And number 7, dy over dt is equal to t plus y over 2y. What do you think this equation is? So this equation is nonlinear. And that's because if you cross multiply, you have the dependent variable multiply with itself, essentially making it nonlinear. Alright, I'm going to give a bunch of practice problems, so you could pause the video here and declare whether each one is linear or nonlinear, and also find out its order. Alright, here are the solutions. So number 8 is nonlinear and its order is 3. You get the order from looking over here, because you remember this is the derivative. And it's nonlinear because it's trig. It's a trig function that utilizes the dependent variable, so that automatically makes it nonlinear. Number 9 is nonlinear and order of 3. As before, d over dx makes this an order of 3 because you distribute it. And it's nonlinear because this is a derivative. The dependent variable is y multiplied by itself. So that means it's nonlinear. And number 10, dependent variable is p. And over here, you already have an exponential with p. So this automatically makes it nonlinear, and it's order of 1 because this is just the first derivative. Alright, here are the last two problems. So you could pause the video here again and try it out for yourself. Here are the answers. So 11 is order of 1 and nonlinear. So this is nonlinear because you have dx over dy times dx over dy. So you're multiplying it by itself, which is nonlinear. And it's order of 1 because this squared, this is what the square means. That it's multiplying it by itself, but you're not adding on another order. So the order is just 1 here. And 12 is order of 2 and nonlinear. It's order of 2 because you take the order from here, so it's just 2. And it's nonlinear because if you move this to the other side, you could multiply this entire equation by y, essentially making it nonlinear.